In this video, we're being asked to prove that M is the midpoint of segment AE. You may look at this picture and absolutely have no idea how to get from what we're given to where we want to or what we want to prove. But in class we've talked about if you've got triangles in your picture and those triangles look like they could be congruent, they're about the same size, about the same shape. Probably want to try to prove them congruent or see if you can. Now, if you can't, you're going to learn through several steps that this is impossible. I want to try something different. But right now, we got two triangles up here. They look like they're going to be congruent. So let's see if we can try to prove them congruent. Okay. So by doing that, when I want to try side side side, or angle side angle, or side angle side, or angle angle side, or maybe even hypotenuse leg. So one of those 5 postulates and theorems that we've seen in class, we're going to try to use to show these two triangles congruent, and then see what I know from there. Okay. So M is the midpoint. That's given. Okay, so that's the first vocabulary word, so that's what I'm going to address first, midpoint. If M is the midpoint, it says it's of WT, so I'm going to highlight W and T. So that's going to tell me that those two segments right there have to be identical. So WM is congruent to MT. That's definition of a midpoint. A point that divides the segment into two equal or congruent segments. Okay. The next thing we know, the next vocabulary word we come across is perpendicular. AW is perpendicular to WM. AW is this segment right here. WM is that segment right there. So you're going to get a right angle right there. Okay. So I'm going to say, and I call this angle W because there's no other angles that share vertex W. So say angle W is a right angle. Next vocabulary word, MT, perpendicular to ET. Okay, those segments. There's ET, there's segment MT. Guess what? Right angle. Okay, so I'm going to also say that angle T is a right angle. I'm going to put this both these under step 3 because it's the same reason. It's the definition of perpendicular lines. Okay, I always ask myself, how do I know those were right angles? Okay, well, the perpendicular lines told me that they had to be right angles. Okay, remember the definition of perpendicular lines are two lines that intersect to form right angles. Okay, so fill in the picture back in. We know that information. What do you always know about right angles? And whether I have 2 right angles or 3 right angles or 1,000 right angles, they're all the same. So I'm going to say angle W is congruent to angle T. All right angles are congruent. Split that, congruent to that. Okay, so we've dealt with 3 vocabulary words, and it got us these 3 steps. Okay, and that's the bulk of our proof. We've got to look at our picture now and say what is hiding in our picture, what piece of information are they telling us that they don't blatantly come out and say in words, but we know it to be true. And that's got to be that angle and that angle being congruent because they are vertical angles. So here I want to say angle WMA is congruent to angle TME. It's vertical angles are congruent. Now the reason I use 3 letters here to name these is because if I just said angle M, you don't know if I'm talking about that angle or that one or that one or that one. Okay, so we've got to be specific on which one. If there's multiple angles at a vertex, you got to be specific about which ones you're talking about. So now looking at my picture, I've got angle, side angle, angle, side angle. So let's say these 2 triangles are congruent. Step 6, triangle, let's go WAM is congruent to triangle. If I went from W to A to M, I got to go from T to E to M. And my reason is angle, side angle. Okay. Now, if that's the case, my overall goal, and I'm going to erase this, but my overall goal is to show that M is the midpoint of this segment AE. Well, if it was the midpoint of that segment, then I would need to know that AM is congruent to ME. Okay. Well, if I look at these two triangles being congruent, AM and ME, okay, based on the picture and the way we've written the triangle congruency, those two segments are corresponding parts. So let's say then that segment AM is congruent to segment EM, CPC, TC. Remember, these two statements usually go together. So now I know that AM is congruent to ME by CPCTC. So that's going to force then that point right there to be what kind of point? Got to be a midpoint. So I can say now M is a midpoint of AE. And the reason is the definition of a midpoint. And the definition is the point that is in the middle of a segment that creates two congruent segments. This point here, M, is creating two congruent segments. So there's your final proof, and you're done.